All right, we are on day 3 of our circle unit, and we are really going to take a new turn here today. All right, first, if you need to pause the video, do so, but you're going to need a calculator right next to you. All right, because we are going to need to do some calculations here today that you'll need your calculator for, so make sure you have that right next to you before you start. We are going on something very, very different. All right, just to show you where we're going here. All right, on your graphing calculator, when we used to do sine, cosine, SOHCAHTOA, and law of sines, law of cosines, every day I start off class by saying, make sure your calculator's in degree mode, which it always should be. All right, but there's always a choice next to degrees, and it was radians. All right, and I don't need you to highlight it on your calculator. I'm just refreshing your memory. All right, there was always something else called radians. That's how an angle can be measured. Yes, you've been doing degrees all your life, measuring an angle in degrees, but it can also be measured in what's called a radian. So the first half of today's video is going to be what is a radian? And then the second half is how do I go from degrees to radians and radians to degrees? How do I convert back and forth? All right. So the first half here, what is a radian? All right. Well, every circle, I got 3 circles here, different sizes. Every circle has a radius. All right, that we could draw in that comes from the center that's drawn to a part of the circle. All right. Now, this is why I love doing this in class with you guys, this lesson, is how many of these radii can I fit around a circle? Here's what I mean. Take a look at my little demo here. Okay, so I have my radius, and I stretch it along the circle. Okay, how many of these could I fit around the circle? Okay, how many could I fit? Well, if we did this out in class with a partner and you measured the radii all the way around, you would find that you could have 6 and just a little more radii that would fit around the circle. All right, so let me say that again. 6 and a little more could fit around the circle, the number of radii that could fit. All right, why is that important? Well, 2 days ago, I gave you this formula. Circumference equals 2 pi r, right? And what was circumference again? What's the definition of circumference? That's the distance around the circle, right? The distance around the circle. Well, r stands for radius, right? Guess where that 2 pi came from? All right, go to your calculators right now and watch. 2 pi. Go ahead. What's that value? 6 and a little more. So that's where the circumference formula comes from, is because I can fit 6 and a little more radii around the circle. Everyone picking that up a little bit. Okay, that's where the 2 pi comes from. All right, you can fit 6 and a little more. Now, instead of saying 6 and a little more, let's get a little bit more mathematical, and we say 2 pi instead. All right, of 6 and a little more. All right, we say 2 pi. So that's where the circumference formula comes from. All right, next, how is a radian formed? All right, how is a radian formed? Well, going back to my example here, all right, when the radius and the arc length are the same, you end up with a radian, okay? Now, we could measure that angle in degrees, all right, but when the radius and the arc length match each other, you end up with 1 radian. Okay, 1 radian. That's what a radian is. Another way to make an angle, another way to measure an angle. All right, and 1 radian is when the arc and the radius measure are the same. All right, one last time to see how our radian is created. Beautiful. All right, so now my question is, how many of these could you fit in a circle? All right, how many radians are in a full circle, 360 degrees? Well, think about it, guys. Think about it. If this is your radius, that matches the arc length matches the radius, how many radii did we say fit on the circle? How many radii fit on a circle? 6n change, also known as 2 pi. All right, so we can have, going back to your notes here, 360 degrees is equal to 2 pi radians. Okay, 2 pi radians. Okay, 360 degrees is equal to 2 pi radians. And if you want to know as well, it's not necessary, but 1 radian is equal to about 57.3 degrees. Okay, about. All right, that's not exact, but 1 radian about 57.3 degrees. All right, so that radian that we just made right here in this example, that's about 57.3 degrees. Okay? And then you guys can start seeing if I went 180 degrees, 2 radians, 3 radians, and a little more, that's pi radians. So 180 degrees is equal to pi radians. Okay, and then I just double that to get 360 equal to 2 pi radians. Okay? So that's the deal with the radian. Okay, that's the deal with the radian. Now what I need you guys have the ability to do is go back and forth. Okay, between radians and degrees, degrees and radians. All right. So first what I want to do with you is to change degrees from radians. Okay, to change degrees from radians. How do I do that? All right. The way I do it is I am going to take the degrees. First thing, I'm going to take the degrees and multiply by pi over 180. Okay? I'm going to multiply the degrees by pi over 180. And then the second thing I'm going to do is I'm going to reduce whatever fraction I end up with. Okay? And I know it's kind of pointless for me to tell you this because we're learning remotely instead of in class, but this conversion right here, pi over 180 is on your formula sheet. Okay, I know you guys can just continuously look back at your notes, but that is on the formula sheet, pi over 180, that conversion. Okay, so let's get going here. So the first one here, convert 30 degrees into radians. So if I have a 30-degree angle, what is that in radians? Okay, so I'm going to take 30 degrees and I am going to multiply it by pi over 180. Okay, now let me do this first, please. Please just watch the video right now and watch me do this. All right, so I am going to take 30 and multiply it by pi over 180. Now I get this. Do you think I really want that fraction that way? All right, I mean the decimal looking like that for you to write that out. No, I do not. So what we're going to do to get more precise, we are going to leave all our answers for now in terms of pi. Okay, in terms of pi. So we're going to leave pi in our answer. So this would be 30 pi over 180. And then you'll notice in step number 2, please reduce the fraction. What does 30 over 180 reduce to? You don't even have to think about it, guys, because remember, your calculator reduces fractions for you. You can just type in as a fraction 30 over 180. And then it'll come up 1/6. If it doesn't, you hit your math, choice 1, turn it into a fraction, and it'll be 1/6 for you. Okay? So 30 degrees as a radian is 1 pi over 6. Or if you want to put pi over 6, that's fine. Okay, pi over 6. Okay, so that's how we're going to turn degrees into radians. All right, so let's keep going here. Next one, 45 degrees. I take 45 degrees. I multiply it by pi over 180. So I end up with 45 pi over 180. And I'm going to ask you to please to reduce 45 over 180. So I go back to my calculator, fraction template, 45 over 180. And I end up with 1/4. So this will end up pi over 4. Okay, pi over 4. And again, I'm trying to connect this as much as possible here, guys. If you remember before, remember what pi was equal to in degrees. Pi was equal to 180 degrees. All right, we showed that on this example right here. All right, that pi was equal to 180 degrees. Well, if you think about it, if you take 180 and divide it by 4, you get 45. All right, so 45 degrees I get by dividing 180 by 4, so I'm going to divide the pi by 4. All right, so it makes sense here. All right, so pause the video, stop it. I'm going to stop it myself for you guys to try out numbers 3 and 4. Okay? Okay, there you go. Those are my answers, pi over 3 and pi over 2. Okay? Let's go the other way now. What if I want to change radians into degrees? Well, now I'm going to take the radians and multiply by 180 over pi now. 180 over pi. And you're probably wondering, what the heck? Where does that come from? Well, remember up above, I gave you that little tidbit. 1 radian is equal to 57.3 degrees. Well, if you take 180 over pi, divided by pi, there it is, about 57.3 degrees. All right, so that's where this conversion comes from right now. And then just like we did again, you don't need to reduce anything here. There shouldn't be a fraction to reduce. Okay. All right, so here we go. If I have 7 pi over 6 radians on number 5, 7 pi over 6 radians, and I'm going to multiply that by 180 over pi. Okay, you will notice from your algebra days, there's a pi in the numerator and the denominator, so I can cancel them. And now I'm just doing 7 times 180 divided by 6. Okay, 7 times 180 divided by 6, that's 210 degrees. Okay, 210 degrees. Okay, let's keep this going. Convert 3 pi over 5 into degrees. So I'm going to have 3 pi over 5 times 180 over pi. Again, pi's cancel each other out. 3 times 180 in your calculator divided by 5. I have 108 degrees. Okay. If you want real quick, go ahead. 5 pi over 3. Don't go on to number 8 yet. That's a little bit different. But 5 pi over 3. So I won't say anything. I'll let you guys work as I show my work. Okay, so hopefully you ended up with 300 degrees. All right, next. Now it's convert 3 radians into degrees. Now, hey, you don't see a pi with it. Okay, that's okay. Radians don't have to have pi's with it all the time. The reason we put the pi with it is to make it more exact and we don't have to write out those long decimals we saw in the calculator earlier. That's the only reason we put pi with it, all right, just to make it look more exact. Sometimes there's not. So here you go, ready? 3 radians, don't add a pi. There's nothing there, all right? It wasn't there to begin with, so don't add it. I'm still going to multiply it by 180 over pi. All right, guess what? It's not going to cancel out. All right, the pi is not going to cancel out here. All right, so I just go to my calculator, 3 times 180 over pi. So 3 times alpha window, 180, get our pi button there. And there you go. And I'll round to the nearest tenth here. So it ends up being about 171.9 degrees. Okay. All right. So if there's no pi with it, don't put it there. Now, real quick before we end the video, why are we doing this? All right. I always want you guys to realize why we're doing this. Well, here's one reason right off the bat. All right. I don't even have to introduce any new stuff. You guys remember yesterday's notes with you guys had length of an arc, right? Okay, you guys had drawing. There we go. Okay, let's say that's 6 inches. Okay, and I wanted to find the length of this arc right here. Well, remind me of the formula, everybody. What was the formula? The measure of the arc, right? Over 360 times circumference, pi times, in this case, 12, d. Okay, well, what if I say that that angle is 6 pi over 7 radians? You can't plug that in here. No, you can't plug that in there. That's only in degrees. All right, this formula is only used when that measure of the arc is in degrees. So you can't plug 6 pi over 7 in there. What are you going to have to do before you use the formula? You're going to have to take 6 pi over 7 and convert it into degrees. And then whatever that ends up being, that'll plug it in. So you guys are going to start seeing here tonight and tomorrow formulas that only use degrees and formulas that only use radians. So we need the ability to convert back and forth so we're using the correct units in the correct formula. Okay, so make sure you get a handle on this as you go to page 9. All right, I'll talk to you guys later.